what I want to talk about is about the joint field and the overlap between learning analytics and virtual reality. So can you give me an idea, whom of you had worked or looked at the field of learning analytics? Just raise your hand. Anybody? So is audio interactive also? Can you say a word what you think learning analytics is?
We will need to come closer because the microphone is in here.
Then we skip that. That's okay. I just wanted to see how far to go with the interactivity. Perfectly fine.
Mhm.
Probably to give you an idea, and I think also what is an interesting link if you're interested to go further in that direction. Last year at the Learning Analytics Conference in Kyoto, there was a workshop on virtual reality and learning analytics, or better to say, learning analytics in virtual reality. And the discussion that is going on is how can we use virtual reality spaces and extended reality spaces to track what users doing and use that to develop, design, feedback, support. I think if I got a glimpse on your last discussion, this was also how, for example, to use then prompting of LLMs in these virtual environments or so to generate feedback, to generate interactivity. In my humble opinion, all this is based on understanding what the user does in this environment. And for understanding what the user does in an environment, if they're on the good path to solve a problem, if they have difficulty solving a problem, you basically need to have measures against which you measure their performance. I give you a recent example. A new PhD started 2 weeks ago at our institute. He is looking at helicopter training and also helicopter training in simulators. And what we want to understand, how are the pilots doing in a training situation in the simulator? And of course, the first thing we need for that is what kind of task they are working on and how they're doing on this task. And then you can define a lot of measures, behavioral measures. They click this and that button. Also behavioral measures on the biometric level, like let's say, what is their heart rate? Are they nervous? What is their cognitive load, if you can measure that, and all kinds of things. So what I want to give you a short introduction today is how can we conceptualize this and what are good examples of how we could, in VR settings, also use different measures to understand what the users are doing, as a consequence then to adapt, personalize, and give further training. So let's get started. I need to move a little bit my screen here. Sorry. First of all, when we talk about training in VR, but in general, we need learning objectives, right? So you might know this, but if you classically, there's one typical paper I mostly refer to. Of course, you can look at cognitive level, you can have affective skills that people develop in social interaction scenarios, which is also very popular to do in VR. You also have psychometric skills that people develop. And typically in psychology, this is differentiated and learning objectives are formulated in these three domains, right? Cognitive, affective, and psychomotoric. Then, of course, you have different theories how people acquire these competences. So if you look at psychomotoric skills, of course, a different theory, like looking at a model, how an expert does this is an important one. But you also have, if you do drill and practice, this is also a model if you look more to simple knowledge acquisition that people need to learn about a number of facts or procedures they have to learn. And then the third level, of course, is which tools and what kind of implementation is most appropriate for that. We less talk about that today because we say, okay, let's look at VR. That's the most interesting part we look at today. So now, if you want to assess these different domains, of course, you can do different things. On the left side, you see, okay, we can start from more skill-based assessments. So let's say, at a good example, an aircraft pilot needs to fly a 90-degree turn. And you can look at all the parameters, speed of the aircraft, at all different parameters in the simulator, and you get basically a performance assessment for a certain skill, right? Other dimensions could be you do it at quizzes if it's more knowledge, but you get cognitive assessment at the bottom line. By the way, do you see my cursor or don't you see? Yeah? And based on that, you can do feedback and adaptation. And you can extend this performance tracking, as I just mentioned. You have data out of your simulation, out of your VR environment. An interesting extension is how can we use eye tracking? Because suddenly, without VR, we have a situation where users mainly just click on a desktop screen. But now you can really track where they are looking. You get the classical eye tracking measures, most of them. And you can also do motion tracking. How do they interact with objects? And last but not least, of course, you can look at behavioral assessments where you embed them in scenarios. A very nice example that reminds me of is Harvard has developed a virtual reality environment in which students have to learn inquiry skills. And basically what they gave them, they put them into a little village, and there was some garbage leaks and some poisoning of the water. And basically they could explore in the whole village and learn about, okay, what is going wrong here? You need to develop an understanding. And the actual thing they were measuring is how systematic students do this inquiry to learn about what is going on and to solve the problem. So, and there are other examples. I think some of them I will give you also other examples, but you get a good picture of. So you can approach this assessment on different levels: performance, skills, behavioral, and complex problem solving. Oops. So now let's think for a moment. What are the special affordances of VR? Because beside the question what we need to measure and how we can measure the behavior in a simulated VR environment, of course, it's also important for what kind of side effects or confounding variables we have in that context. Of course, there's enough evidence that has shown that VR is very powerful for experiential learning, right? You can design a full-fledged environment. You can reduce the complexity also, but there is also a risk that it is overwhelming. So you need to, in a sense, if you come from a psychological perspective, it needs to be very focused on the task you perform. Otherwise, you're measuring a lot of side effects you probably don't want to have. There is, and this also is shown in the evidence, of course, you have the ability to reduce the complexity because you can just remove objects and focus on that. There is positive evidence for example, for the autism spectrum or users that have special needs. There's also a very positive evidence about settings where you do deliberate practice. So where you have to repeat activities and you try to get better and better. I come back to my original example. Pilot, of course, you can practice these things or certain maneuvers only in the VR context, and it's nearly impossible, some maneuvers, to try them in a certain airspace you have available. So, for example, then the pilots have to go to really another physical location to train that. And last but not least, there is, of course, the potential to collaborate across different platforms. So now let's try to put things together and contextualize in the context of the VR for VET project. A lot comes down to the question what kind of tasks we design in the VR environment, what we have done with a scenario-based approach. So you select a scenario. I speak for our case about the cloud engineering scenario. Then you drill down to certain tasks you have to do, certain knowledge you have to develop, certain performances like working on a ticket, more complex problem solving, and so on. But the tasks, of course, are also related to the underlying model of career development, because the purpose is not only that, or the minor purpose is that students learn to solve a problem in the environment, but it's much more important, oh, now I lose my mouse, that they develop self-awareness, opportunity awareness. So what is the environment about? What could be the daily practices in this environment? What kind of decisions do I need to take? And what would be my path into such an environment? And I've did a little exercise. I think this is even, sorry, I missed out the quote. So you can consult GPT, of course, also. I just wanted to have the kind of inventory, so measurement instruments that can be used for these different parts of the DOTS model. Yeah, of course, there are questionnaires that look into more career consulting perspective, but there are also things like you get ideas about tools where you use other sources like peer feedback. You get tools, measurements more on the self-awareness. This is just to give you an idea. It's not validated, so I recommend to take this information carefully, but there is a variety of already established assessment inventories to assess what, for example, is the situational awareness of a user, how do they perceive a situation, are they aware of the important factors, and so on and so forth. So now this as a background. To summarize, you have different ways to assess the behavior of a user in a virtual environment, right? We talked about performance, we talked about knowledge skills, we talked about the effective probably behavior. And now I want to give you some examples of what we could observe, or what we can observe actually in VR, and how to use that. So I start with a simple example that is actually not headset-driven VR, but I think it's a good example on how we can use virtual worlds in general. And we did a lot of work at the Center for Education and Learning in Minecraft. We modeled the whole campus during COVID. And here you see some examples what we did on that campus. First of all, you can measure where do avatars or people go? Where do they, what buildings do they inspect? You have on the lower left image, you have NPCs. So we had NPCs distributed over the whole campus. So you could see what kind of interaction they had with which campus. Did they check all the landmarks we proposed them? We had a guided tour. So we could see some puzzles also they needed to solve on the campus and so on. So main points of observation that we can measure here, what objects they interacted with and with which NPCs they interacted with and in what way. Second, we had a creative world linked to the same campus, and we simply gave the students the opportunity to create their own buildings. You see some examples. This was a really nice experience because they did not only construct standard buildings, but really also constructed new kind of, did new kinds of construction related to their upcoming study. And here you could already see what kind of materials and structures they used and the type of objects they created, right? And last but not least, this was mostly to measure, and just to give you an example, for measuring cooperation, because this is, I think, a very interesting challenge and very interesting opportunity. How they interacted in a survival world where they had to collaborate to solve certain problems. So now to apply this more to problem solving, in a seminar I give yearly in Delft, students developed also, for example, escape rooms in Minecraft. In this case, it was about logic gates. So they had students, they had to solve a problem also collaboratively, because they had to, for example, interact with different levels or layers, and to solve a logic gate problem. We can track what problems they solve, whom of the group is contributing what to the problem, and so on. Same here, this was more like knowledge they built up. This group did a modeling of a geology museum, and they had to learn, so you could see on different levels of the museum going underground, they had different problems to solve. This was more knowledge oriented. So now, how do we use this in concrete studies? This is one example that is built by the New Media Center in Delft. It's, to my knowledge, I think there's some more information. Yeah, first year bachelor. And then students go, this is a VR environment. They go into the environment with 2 to 4 people. They basically have 3 tasks: find objects, use the crane, and transport a large section. And this is done as a kind of onboarding exercise for first year students, to really get an idea of what is the shipyard looking like, what are the main objects in the shipyard, and how do I interact with those. This is basically, yeah, just for onboarding. But you see the same examples I demonstrated before in Minecraft also applied here. And we used also some of those in VR for VET, for the basic task designs, as, for example, in the cloud engineering, getting to know which memory storage is available, which hard disks are available, what is the logic of a board, and so on and so forth. So a big advantage of, or another big advantage of doing VR simulations and assessing behavior is, of course, that we can measure at scale. Not only that we can measure things that were really difficult to measure before, like eye tracking. This is really complex. I remember a colleague of mine, there are now eye trackers that are as big as my glasses, and I could track where I'm looking in the classroom. Halchka Jarochka, one colleague of mine at the Open University, did such studies, but it's really complex in a real world scenario. Of course, in VR, this is much easier. The same with measuring at scale. This is an example from the architecture department in Delft. And basically, they have been modeling some new city parts for the city of Amsterdam. And basically, people went or walked through the virtual scenario, and they could exactly track where are people looking, and created hotspots, probably also could identify problematic settings of the environment, and so on. So this was used for environmental design and architectural design and feedback on that level for the designers. Yeah, basically. Here you see a bit like you could do, this is a typical evaluation. I don't know, whom of you has worked with eye tracking before? Anybody? Basically, a typical visualization you get is what you see here on the left side. These are so-called hotspots. So when you do a classical eye tracking, let's say for a website or for marketing, you then typically get the hot or red is for hot zones. This is where people look a lot, right? So this can indicate zones of attraction or confusing zones. This can be interpreted in different ways, but you can do the same thing basically, and you see an example here in VR environments. So this is collecting data for the designers. Collecting data for performance of experiments. This is a series of experiments that also the New Media Center has developed. You start basically with a browser for all the text, I hope. Yeah. And you see an example. You see the movie moving, right? Or is it static? Yeah, you see it moving. Yeah, okay. So this is an experimental setting. I think it's from a course in also mechanical engineering, or I think so, yes. And you can perform different experimentations. And you have to select the parameters and so on. You have a measurement instrument. And they did this for different settings. The two main advantages of this kind of setting is you can measure the individual performance and record this. And not only for the student to export the data, but of course also on a bigger scale. Like you get 100 students and they can repeat this 50 times and you get all the data from these interactions. So I think this is a very powerful approach to using VR in large-scale training, as we have to do in courses at the University of Engineering. And additionally, it's also very interesting where you have, of course, restricted access to resources. One other simulation where currently that is developed is a simulation of a robot arm. And of course, not all students can use the robot arm. There are limited time windows to use or get access to the robot arm. But in VR, of course, they all can practice beforehand. All right. I think I skip that part. Oh, I guess I need to do. Yeah, let me go to the next one. How can I go to the next one? Sorry, I think I need to keep this running. But you see some more examples of the lovely modeling and things that are done at the New Media Center in Delft. Those colleagues really focus on development of new studio facilities and modeling of facilities for practice and use in such training scenarios. So, second part, I think the main message from me is here, and I just gave you 3 reasons. The scalable assessment, and I gave you some examples where we can collect data of eye tracking, where people look, how they solve problems in experiments with a very dedicated task, how we can scale up this in environments where they solve complex problems. So another approach we looked into in the past in a project, and this is probably applicable for other scenarios, is when you measure a user's performance and you need to say if the person is an expert or a beginner. Let me ask you one question. What do you need? If I want to say if Michael is an expert in playing tennis or table tennis, let's put it that way, and I have observations of his performance, then I'm missing one critical component that I need to have. What is that? Any thought? I have exact measurements of how good Michael is performing.
We need some metrics as to what like good performance should look like. I don't know if you
Yeah, I can hear. I need the metrics. I need the metrics on what to judge him. And what else do I need?
A threshold where you can already call me an expert.
How do I get a threshold?
You need enough data from other experts.
Exactly. So I need not, in the best case, you do not only have an expert's opinion, of course, that also helps, but let's say if I would probably have a baseline or a threshold, like you said, Michael, of a world-class table tennis player, okay, then I can rank you on what level you are. Yeah, so that is my main point. And I think a very elegant way, or elegant way, how we did this, and some of you know this work, is in the WeKit project, where we basically, the core idea, or one of the core ideas, was to record an expert performance to compare that to beginner performance. And you can apply this to all scenarios we just before, I showed you before. You can ask the expert to diagnose the system in the Minecraft world. You can ask the expert to run with a team of experts through the virtual shipyard. You can ask the expert to do the cloud engineering scenario. It's always the same component. And I skipped this video because this is another example of that Bibek Limbu, one colleague of us, developed. It's a calligraphy trainer, but it illustrates the principle. You see on the right side, or on the left side, you see the setting. Basically, it's about learning to write a character. Or you can use it for any kind of sign. In this case, Bibek is Nepalese, so he taught people to write Nepalese characters. And basically how the system learns to compare a student's performance to an expert performance is that the expert writes the character, let's say 5 to 10 times beforehand. And from all the parameters, you can then extract how a performance of an expert looks like. How fast is the speed? How strong is the pressure? How shaped are the angles, and so on. And you can use that expert model to generate a machine learning model, or train a machine learning model, better said, to give feedback. And this is exactly what Bibek did in that case, and what we are also trying to do in projects like WeKit, and what could probably also be a next step, or we partly integrated that from my perspective in VR for VET in more collaborative training scenarios, so that you can so well observe an expert as also use observations of experts in a virtual environment as training data for giving feedback to novices. Another good example, I had a student group that worked with SenseGlove. SenseGlove is a startup from TU Delft, and you see here, basically it's a feedback instrument for haptic feedback on the hands. And the students developed a guitar playing training application. So basically, with the gloves on, you play the guitar. You can, a person that can play the guitar, recorded the settings, how you stroke, how you grip, and then from that model, you can basically give feedback to novices that try to learn the guitar. So, summarizing. I started a bit about observing learner behavior, observing behavior in the virtual environment. On the left top, you also see last example I gave you. It's very interesting also to look at the capturing of expert performances in these virtual environments. In a lot of cases, you need to really get the baseline we talked about, the comparison. To do that automatically, you need kind of annotation or pre-processing of your data and train machine learning models or classifiers to look at how to compare this expert behavior with the student behavior. And at the beginning, we talked a little bit about what kind of feedback you can generate or assess the level of the student. And this is, of course, performance on a task. You can develop sequences of tasks or change parameters of the task, and in that sense develop models for deliberate practice in the virtual environment. All right, last but not least, I'll be brief on that, but I show you that. So now when we extend this, and I gave you some scenarios also on collaborative learning, I think this is a very nice one. And I've seen several similar applications. In this case, a virtual medical model is used. Here, we're working with augmented reality, and basically we have a visualization of a patient, and what the students learn or should learn in this case is doing a diagnose of the potential lung disease, of the status of the patient. And we use the audio, especially in this case. So you see, we could track where you hold the listening device on the virtual patient, and that is basically used for diagnose development. An important part of the learning and also developing the awareness is, of course, the discussion between the two students in that case. A similar case has been developed for airplanes and visualizing different subsystems of the airplane. And there you again see the case, I think, that the discussion between the students and the exchange with a potential lecturer in this scenario is very, very important for the progress. All right. So at last but not least, I show you one part of where we try to understand now how this collaboration in VR environments works, and how especially we can see what kind of collaborative stance or collaborative approach students have to jointly solve problems. How did we do that? Basically in the VR environment, we could visualize for others where the students are looking. I give you an example to make that more concrete. Let's say I take again the cloud engineering or the blue sector, it doesn't matter. You go with not only one student goes through the scenarios, but you have 3 students going through the scenario, working that one student illustrates the task, the others watch. And then in some cases, it's really important to see where the person is looking. Yeah, so kind of deictic reference to the object. And in the experiment, we use that as one factor. So one part in the experimental design, one part of the group had this visualization, the others did not. And it clearly showed that having this possibility of visualizing where I look at and doing this continuously contributes to the learning and to the development of understanding what is going on in the environment. That's it. I gave you a very short glance. Let me wrap this up with coming back to the overall picture. I think both to develop awareness, understanding what is happening in an environment, also to give career consulting. We need to understand what users do in these environments. And one way to do this, of course, is tracking them in their behavior in the environment. We talked about 3 rows. We can look at their performance. We can give them some specific tasks for that, but we also can ask them questions about what they have been seeing, or introduce them to new environments and objects and just learn more about facts. Or we give them environments where they can do deliberate practice and continuously or repeatedly practice certain activities. I tried to give you a little bit an overview of what design parameters you have in VR to do that and what to measure.